Good morning or good evening, wherever you are. My name is Lucas Aronson, and I'm a principal geotechnical engineer at BGC in Vancouver. And it's an absolute pleasure and honor to introduce our keynote speaker of this first session, Professor named Sarah Springman. Sarah is a geotechnical engineer, graduated from Cambridge University, and has been really doing work on soil structure interaction, soft soil mechanics, and specifically also geotechnical centrifuge modeling. Personally, I had the pleasure of having been Sarah's first doctoral student when she was a professor back at ETH Zurich in Switzerland. And she led really pioneering visioning work on mountain permafrost and the impact of climate change on slope stabilities in mountainous terrains, which, as we know from recent events, became more and more important over the recent year. In 2015, she then moved more to an administrative role as rector at ETH until 2021. And then 2022, she moved back to the UK and is now principal of St. Helda's College at the University of Oxford, where she's inspiring future generation of engineers, but also mainly of leaders. And it would take way too long for me to go through all her academic, but also sporting achievement, and more specifically, what she's doing, her dedication to people and organizations behind those. However, I still want to highlight that Sarah was this year's Terzaghi lecturer, and prior to that, she gave a very interesting interview with on the GI Director's Cut, which I encourage everybody to check. So, with that, I want to pass it over then to Sarah, and she's really a testimony of how teamwork is important, excellence, curiosity, common sense, and clarity, combined with visionary leadership. So please join me in welcoming our first keynote speaker and great mentor named Sarah Springman.
Thank you so much, Lucas. I have to say that without Lucas, I really wouldn't be here. So he was on my selection panel, and this was a really very important point to make. So thank you very much for that, Lucas. I'm now trying to find, I managed to share it all before. Where is it? Oh my goodness, the world has gone mini Terzaghi lecture. Can anybody see that? Can you see my lecture at all? Has it come out? No? Yes?
Not yet.
Not yet? Okay.
Yeah.
Yes,
now,
it's there.
Perfect.
Brilliant. Excellent. Well, I'm very honoured to come and join you this afternoon, and I'm now going to try and talk for 30 minutes, and I will stop. I've got lots of slides, and I'm just going to go as far as I can to share my ideas, but you'll get the slides afterwards. And I want to think about suction, saturation and stability, and I shall look at the impact of rainfall with a little bit on bedrock and vegetation, depending on how far I go, on landslide, occurrence, and particularly related to some field tests that we conducted in Switzerland. You'll see pictures of ETH Zurich on the bottom left, and where I am now at St. Hilda's on the bottom right. So here is an example of a series of landslides from a storm in the summer of 2005 in the centre of Switzerland. And compared to the 30-year averages, July 2005 had very little rain. It was about 10 or 30 millimetres less, whereas August was much, much wetter with about 70 millimetres more. And as you can see by the 48-hour record on the left-hand side. On the right-hand side, you can see lots of landslides, smaller than 1,000 cubic metres marked in brown, and those up to 100 times larger by volume, up to and over 100,000 cubic metres are shown in the green circles. And climate change means that the more extreme storms are likely to cause even more problems in the future. So this slope shows you, and we can see where it is in sort of north-central Switzerland, lots of small slip failures all over and around the farms. Nothing really serious, nobody was really injured or damaged, but the question is, what influences the initiation of failure through rainfall on existing slopes? what role do slope angle, soil type, depth of bedrock and the permeability of bedrock play, and when is water a factor in terms of flow and springs and slope drainage? So I'm going to discuss that a little bit with you. And what I want to do today is to share what we've learned from a couple of field and laboratory tests. The one on the left is a 38-degree steep instrumented slope. And we also did tests in an alpine moraine. You can see a large in situ shear box designed in by our workshops, by our engineers, and they were absolutely produced amazing data, and also a rather large triaxial test, 1/2 meter high and 1/4 meter in diameter. And what we learned from that to try and quantify a bit vulnerability and establish be able to establish an understanding of the hazard and the phenomena, and eventually protect infrastructure and lives. And we might refer a bit to the centrifuge. I've skipped the analytical and the numerical modelling at this moment in time. So the two field tests I want to talk about are one in the south of Switzerland in Gruben, which was a granular moraine slope, and the second was a sandy forested slope in a place called Rüdlingen. And you can see that when we look at the map of Switzerland with some stochastic analyses with certain assumptions that I'm not going to go into, it's in the notes. You can see that in the south you expect in this area that the slopes are unconditionally unstable, whereas up in the north they are unconditionally stable. So we have two different zones that we're looking at, and we'll talk a bit more about that later on. This shows a lovely pictures of Switzerland. One on the left is the elevation. The highest point is 4,633 meters, and the lowest is just under 200 meters above sea level. And you can see in the south we're up just under 3,000 meters above sea level, whereas in the north we're probably around about 200. And on the right hand side, again, you can see the typical slope angles range from virtually nothing or local slopes to obviously rock slopes at 78 degrees. And I'm going to use slopes as a little bit of a guide for us to explain whether or not we think we're going to be near failure or not. Now, and you can see the Alps again going across the south west to the southeast of the country, and the Mittelland in the middle, and then there are some limestone mountains in the north, the Jura, which is the extension of where we found the Rüdlingen landslide area.